Hey guys, so today we're going to be doing the linked list implementation to go along with the linked list theory video from earlier. And so I'm going to sit here and bang this thing out, show you how easy it is to write this stuff. And then I have some notes prepared that we'll go through. I want to keep these implementation videos shorter than the theory videos. So I'm not going to spend too much time on the notes. I'm going to go through them with you though, and then the notes will be available in the GitHub repo to the lesson. So check out the GitHub repo in the description, and there's instructions there for how to access, all this stuff. Okay, so let's get started. Let's write some code. All right, so first thing we need is an enumeration called list. So we're going to create our node first. Okay, and so what this is, remember, we got our node, which contains our value and the pointer to our next node. Okay, so we're going to implement on list. We need a constructor. And then we can do just an empty list. Now we need a way to add things. So we're going to move self, we're going to pass in an integer, and then all we have to do is this, and then create a new pointer to the next node, self, right? So this is going to be in is our new value, and then self contains our current value, and so we're making a pointer to it, and then putting the new value in the front. All right, so now we also need a way to find out the length. Pass a reference to self. This is going to return a number, and then we match on self, and then a self nil is 0, and then self. We do not need head because our entire linked list is stored in tel. And so to make up for that initial value, we do 1 plus tel and then call that recurse. I'll talk about this in the notes a bit, so don't worry about it if you're confused by the recursion bit. All right, so now we need a way to see the thing, a string representation of the linked list. I forgot to mention this in the theory video. Come down a little bit. Okay, so we're going to match on self again. If we get nil back, if we get nil back, then we're going to return nil. Okay, and then if we get our head and tel values back, we're going to use our string builder, our format macro, and then we're going to do head and then tel. That's right, stringify. Right. So what this is going to do, so this right here, right, we're not getting any value. All right, this isn't returning anything. We're solely using this to access that head value and reach our base case, which is nil. Right. Talk about that in the notes as well. Okay. Now the last method is just reversing the thing. Right. And then, so this is going to return a new. So this is going to return a new list. Okay, so no, okay, and then this is going to equal self. Okay, we're going to return the reverse. Now we're going to do some destruction. Okay, while let here head tel equals current. We're going to do rev, same thing as we did in the prepend. Self con we got a dereference head, and then box new rev, right? And then current is tel, the next node. Okay, so what we're doing here is we are destructuring current. We're taking the value from head and grabbing that and then creating a box to to the previous version of rev, right, and then storing the next node in tel. We'll go through in the notes if you're confused. Okay, and then we return rev. Okay, and that's it, guys. 41 lines of code. Okay, so let's go over to main and let's do a quick implementation of it. So let's do let linked list equals new. Let's prepend 3, 5, and 7, and then we can do the reverse one. We'll do L list dot reverse and stringify, so we can see what it looks like. Okay, now let's see what this thing actually looks like. So we have our elements, which is going to be list.stringify. All right, and then we got the number of elements. Right, and then we have our reversed list. Yeah, that's all we need for that. Okay. All right, there we go. All right, so our elements, 7, 5, 3, nil, right? Because the elements, as you add elements, the current head is pushed back. And then the number of elements is 3, nil doesn't count. And then when we reverse the elements, well, they're reversed. Okay, so nice, that's done. All right, so now let's walk through the code in a little bit more detail and let's look at these notes, okay? So I'm going to pull Notion up over here. I'm going to go up to the top. All right, so our linked list implementation, I have the code also here. So our prepend method, okay? So like I said in the code walkthrough, what we're doing here, okay? So the key thing to understand here, where people get most confused, is self being the current node, okay? And so I kind of do a little run through here, right? So when we create a new node, it's just nil, right? It's basically an empty pointer, okay? And so after prepending the first node, let's say we're going to do 7, we get nil, we get 7 and then nil, right? Because nil is self. Up here, nil is self. That's the initial value, okay? So it looks like this, okay? Then after we prepend 5, 7, nil is what it was before, and then afterwards 5, then we actually get a pointer to the next node, okay? So this is what it would look like if you were to build this out by hand, right? If you were to manually build this structure out, this is what it would look like. You see there's this embedding that goes on, this kind of natural recursion that happens when you use box. That's really useful for situations like this and can make your code a lot more succinct. Okay, and so look through that, read through that. If you have any questions, really, guys, what I want to drill home there is just the logic of self being the current node, right? That you're pushing, that you're going to be adding and pushing, that you're replacing, right? Okay, so then the length method. So the length method, the only thing that really trips people up here is, once again, the way that the recursion is working. I'm going to have a separate video, guys, on recursion and matching. I was going to have 2 separate videos, but I think I'm going to do them in both the same one. So that may be up. So if you want to know, if you need to learn more about recursion to really grasp it, you can watch that if it's up. The recursion stuff is fundamental, guys. You need to understand it. Okay, so what I'm going to do, I think this is the better one. I looked at both of these. I think this is a little bit easier to understand. Okay, so on the initial call, right? So the way that recursion works is it builds up. It stacks, right? And so what happens is you stack, and then when you reach your base case, it unwinds, right? So all those returns that kind of built up, until you reach the base case, they start unwinding, right, in reverse order. So for instance, okay, so when we call len on our first node, right, on this one right here, on the 7, okay, 7's ignored, okay, 7 is ignored here because that's what's in the head. That's the underline. This is this, right? So this is 7, right, initially, okay? Then when we do tail.len, we're going to get 0, okay, but we have 1, right? That's what this 1 is for, is to account for that, right? So we have that 1. And then on the second call, we get that last return, right? And then on the last call, the same thing happens, right? And so it's really just kind of wrapping your head around the way that recursion stacks and unwinds. Okay, hopefully this helps you out. If not, like I said, I'm going to make a video on this. I'm going to make a video just on recursion because it's very important. Stringify. So I mean, this basically works the same way as len does, except what we're doing here is we're using head, right? So what we're doing, so tail.stringify, this method doesn't return anything. It just calls itself, right? And so all we're doing is we're going through and grabbing those new head values as we go through the list. And then when we hit nil, our base case up here, we're going to get that string nil, right? And so very similar in functionality to how we do the length stuff. So there's some more notes here. These notes were, I wrote these notes out earlier. I was going to have 2 separate videos on match and recursion, but I'm going to include them. So this won't be there when you see it on GitHub. And then finally, we have the reverse method. So guys, this method, this works almost just like the prepend method, right? And so, you know, we're just creating a new list. This just stores our new reverse list. And then this just stores our current node, which is self, right? Once again, self is the current node. So, and then in our destructuring, we're just adding the current node to the head, right? We're just, you know, since we're doing destructuring, we have to dereference. And so we get that dereference, that head value, and then we just create a pointer to the previous head value and then store the next value in tail, and it goes back through. Because if you see this, guys, this right here, it's the exact same thing that's in prepend, right? So look, bip, bip, it's the same thing, okay? So yeah, so that's it. There's some more notes. I go through here and I actually go through and break down the destructuring a little bit more. And go through 2 iterations of it. So let me know if you guys have any questions about this stuff. Help each other out in the comments. Ask respectable questions and you'll get respectable answers. And yeah, hope you guys dug it. Hope you learned something. And we'll see you in the next one.